Alright, so here's where we start doing stuff that's exciting. Um, I want to talk about revolving shapes and getting three-dimensional figures and talking about their volume. And so I'm not going to do any calculation in this video at all. This is just going to be pictures and cool stuff. So the first thing I need you to do is over here on the right, sort of mentally consider what does f of x equals x squared plus 1 on the interval from 0 to 2 look like. So between 0 and 2 in the x-axis, what does that look like? So hopefully we all have a strong sense of that. That should just look like this parabola shape, and if it's between 0 and 2, we're looking at sort of the region there. Last week we would have computed the area of that, and that's fine. But what I want to talk about in this video is this first question here. Imagine that we revolved that region around the x-axis. So if you took that shape and like revolved it around the x-axis. So I almost imagine like, imagine that you could grab the x-axis and like spin it in your fingers so that the thing, this gray region, sort of sweeps out of your computer monitor and back down and around the back. And a follow-up question to that, if I were then to take that solid thing and cut cross-sections perpendicular to the x-axis, what shape would they be? Now, the good news is I've got this awesome program called Maple that will let me show you what this thing looks like. It looks like this. And the scale isn't quite the same here, but the idea is, so if you imagine taking this shape and you revolved it around the x-axis, it would certainly flip down, to this section down here. But what's more is that the thing would actually be a volume, right? Like if I mean, again, imagine that you're taking sort of this, this is the parabola shape here, and when you revolve it around, sure, it's going to land down here in the negative section, but the thing's also going to be three-dimensional. Like it's going to sort of be this like horn-shaped thing. And the next couple of lessons are about how do I find the volume of that thing, right? So question 1, the solid would look like this. Question 2, if we cut cross sections perpendicular to the x-axis, so I don't know how to rotate this thing very well, I'm not very good at that. This is the x-axis. If I were to cut this way, or down this way, anytime perpendicular to the x-axis, notice that the shapes would all be circles, right? And I'm going to leverage that in the next video to actually find the volume of this thing. Let's take a look at another example of the same thing. Let's see here. So now I've got a new shape for us, right? What does this function, 1/2 sine x plus 1, so imagine taking the sine function, multiplying it by a half, adding 1. Think about that area between 0 and 2 pi. I should have given you more time to do that, sorry. That's the shape that we have, right? I mean, you've got this gray region here. I'm going to ask the exact same two questions. Imagine that I took that shape and revolved it around the x-axis. What would that solid shape look like? And I'm pausing for a moment to let you think about it. You might want to pause the video yourself and think about it. I'll give you a hint. It's a somewhat common household object, that you can hold flowers in, I suppose. The thing should effectively end up looking like a vase, right? If I take this shape, revolve around the x-axis, it'll sort of flip down into the negative, sort of the fourth quadrant. But again, remember, this thing is in three-dimensional space. Like it exists. I mean, you could put the flowers in the top here. Presumably you'd want to have a bottom on the vase, because otherwise, all the water would fall out. But we can sort of imagine that this is this three-dimensional volume. And again, they're always, when I use Maple to do this, it ends up making it a hollow thing. When we're working with them, we actually want them to be solid, and we're going to be finding the volume of the things. But we'll get to that. So again, what if I cut the cross-sections perpendicular to the x-axis? So again, if I cut down this way, down this way, down this way, down. Anytime I cut this way, I'm going to end up with a circular cross-section. Okay? I have one more of these for us to look at, and I'm going to mix this one up just a little bit on us. So this time I want us to look at the region in the first quadrant, so only in the first quadrant, that's bounded by x squared, x equals 0, and y equals 4. So pause the video and just draw those functions, draw those shapes, figure out what region I'm talking about, and I'll scroll down and show you that in a second. So the region you should have found is this guy, right? First of all, you've got x squared here. You've got y equals 4, the horizontal line here. You've got x equals 0, that's the y-axis. And since I said it's in the first quadrant, you know you're looking at this region here. Now this question is asking something different. I'm not asking what would happen if I revolve this around the x-axis. I'm now saying, what if I revolve around the y-axis? What would that solid shape look like? So again, thanks to Maple, we can take a look at this. If I were to take that parabolic shape and revolve it around the y-axis, it would end up with sort of almost like a bowl-shaped thing. What I think of this more as is like a searchlight reflector, like those giant searchlights they put up. You could imagine there's a light bulb sort of sitting in the middle of this thing, and it's shining this beam out. Because you could put like the Batman logo in here, and it could be like the bat symbol. But anyway, we've got this shape here, right? Now, my previous two questions I asked, what happens if I take cross-sections perpendicular to the x-axis? If I were to take cross-sections of this thing perpendicular to the x-axis, I'd basically get parabola shapes, which is kind of weird. Because I revolved around the y-axis, I'm interested in the cross-sections that are perpendicular. So what happens when I cut this one sideways? What happens when I take cross-sections perpendicular to the y-axis? Well, you'll notice once again that they are circles, right? They're larger on the top. They are, I don't know if you'll be able to see it this way, they're basically smaller on the bottom. But the cross-sections that I get perpendicular to the y-axis are circles. In the next video, I'm going to go through how we actually compute the volume of these things. The whole purpose of this video was just, can you figure out what shape these things are supposed to be? And so that's all I have in this video. I will see you in the next one where we actually do some computation.